Welcome all. Today we are going to discuss about the Jacobi iteration method, which is required to solve the simultaneous equations. Jacobi iteration method is also known as the method of simultaneous displacements. Let us consider the system of linear equations as a11x1 plus a12x2 plus a13x3 is equal to b1. Second equation as a21x1 plus a22x2 plus a23x3 is equal to b2. Third equation as a31x1 plus a32x2 plus a33x3 is equal to b3. Suppose these are the three simultaneous equations of which x1, x2 and x3 values we are supposed to calculate. Here we assume that the coefficients a11, a22, a33 are the largest coefficients of the respective equations, so that the a11 mod value is greater than a12 plus a13, the mod value of a22 greater than a21 plus a23, the mod value of a33 greater than a31 plus a32. The Jacobi iteration method is applicable only if the above condition is satisfied. Now we can write x1 is equal to 1 upon a11 in bracket b1 minus a12 x2 minus a13 x3. We have just separated the x1 values. Similarly, we can separate the value of x2 as x2 is equal to a1 upon a22 in bracket b2 minus a21 x1 minus a23 x3. Similarly, we can extract the value of x3 as 1 upon a33 in bracket b3 minus a31 x1 minus a32 x2. Let's the initial approximations as a0 x1 initial approximations as x1 0, then x2 0 and x3 0 respectively. For the first iteration, the x11 value is 1 upon a11 in bracket b1 minus a12 x02 minus a13 x30. Similarly, we can calculate x21 as 1 upon a22 in bracket b2 minus a21 x10 minus a23 x30. Similarly, we can find the value of x31 as 1 upon a33 in bracket b3 minus a31 x10 minus a32 x20. Here we have just separated the value of x11, x21 and x31, and we have put the respective value of first initial approximations. For the second iteration, the improvement is obtained as x12 is equal to 1 upon a11 in bracket b1 minus a12 x21 minus a13 x31. Similarly, x22 will be 1 upon a22 in bracket b2 minus a21 x11 minus a23 x31. Similarly, you can find the value of x32 as 1 upon a33 in bracket b3 minus a31 x11 minus a32 x21. Now let us solve the example by the Jacobi method. The equations are 15x plus 3y minus 2z is equal to 85, first equation. Second equation, 2x plus 10y plus z is equal to 51, second equation. Third equation, x minus 2y plus 8z is equal to 5. Here we have to check the diagonal elements which should be greater than the summation of the respective other elements. 15x is greater than 3 plus 5, 3 plus 2, 5. 10 is greater than 2 plus 1, 3. And 8 is greater than 1 plus 2, 3. So that's why we can solve this equation by the Jacobi iteration method. In the above solution, we can check 15 greater than 3 mod value of minus 2, 10 greater than 2 plus 1, and 8 greater than 1 minus 2 mod value. So that's why we can use here Jacobi iteration method. Now x3 is equal to 1 upon a1 d1 minus b1y minus c1z. Here we have replaced the respective value of a1, d1, b1, c1. So you can get 1 upon 15 in bracket 85 minus 3y plus 2z. Here we have separated the value of x from the first equation. Now for the second equation, we can separate the value of y as y is equal to 1 upon b2 in bracket d2 minus a2x minus c2z. Put the respective value of b1, b2, d2, a2, c2. You will get 1 upon 10 in bracket 51 minus 2x minus z. For the third equation, we have to extract the value of z. The value of z is extracted as 1 upon c3 in bracket d3 minus a3x minus b3y. Put the respective value of c3, d3, a3 and b3. You will get 1 upon 8 in bracket 5 minus x plus 2y. These are the equations we have extracted from the first, second and third equation respectively. Now for the iteration 1, let us assume the first initial approximations as x0 is equal to y0 is equal to z0 as a 0. So for the first iteration, x1 is equal to d1 upon a1. So that's why it will be 85 upon 15. Indirectly it will be 17 by 3. For the second equation, it will be d2 by b2, which is equivalent to 51 by 10. For the third equation, it will be d3 upon c3, it will be 5 upon 8. Here the remaining terms are missing because the initial value of x0, y0 and z0 are 0. For iteration 2, x2 will be 1 upon a1 in bracket d1 minus b1 y1 minus c1 z1. Put the respective values of previous iteration here. We can get 1 upon 15 in bracket 85 minus 3 into 51 upon 10 minus 2 into 5 by 8. Here we have taken the respective value of y1 and z1 from the previous equation. So it will become to x2 is equal to 4.73. Now we will use x2 value in the next iteration. y2 is 1 upon b2 in bracket d2 minus a2 x1 minus c2 z1. Hence 1 upon 10 in bracket 51 minus 2 into 17 by 3 minus 1 into 5 by 8. Here we have taken the value of y2 at 3.904. For the z2 of second iteration, 1 upon c3 in bracket d3 minus a3 x1 minus b3 y1. Here put the respective value of x1 and y1, you will get 1 upon 8 5 minus 1 into 17 by 3 minus 2 into 51 upon 10, which is equal to 1.192. Hence z2 is equal to 1.192. For the iteration 3, x3 will be, here we have to put the respective value of x2, y2 and z2 of previous iteration in this case. So that's why x3 is equal to 1 upon 15 85 minus 3 into 3.904 plus 2 into 1.192, which is equivalent to 5.045. Now y3 is equal to 1 upon 10 51 minus 2 into 4.73 minus 1 into 1.192 is equivalent to 4.035. Z3 value is 1 upon 8 5 minus 1 into 4.173 plus 2 into 3.904 is equal to 1.010. Now take the respective value of iteration 3 in iteration 4. So iteration 4, x4 is equal to 1 upon 15 85 minus 3 into 4.035 plus 2 into 1.010, which is equivalent to x4 is equal to 4.994. y4 is equal to 1 by 10 51 minus 2 into 5.045 minus 1 into 1.010, which is equivalent to 3.99. z4 is equal to 1 by 8 in bracket 5 minus 1 into 5.045 plus 2 into 4.035, which is equivalent to 1.003. As you can see, we are coming to near 5, 4 and 1. Iteration 5, x5 is equal to 1 upon 15 85 minus 3 into 3.99, which we have taken from the previous iteration, plus 2 into 1.003, which we have taken from the previous iteration, which is equivalent to 5.002. y5 is equal to 1 by 10 51 minus 2 into 4.994 minus 1 into 1.003, which is equivalent to 4.001. z5 is equal to 1 by 8 in bracket 5 minus 1 into 4.994 plus 2 into 3.99, which is equivalent to 0.998. All these values we have to take from the first iteration. Now sixth iteration, x6 is equal to 1 upon 15, 85 minus 3 into 4.001 plus 2 into 0.998, which is equivalent to 5. Y6 1 by 10, 51 minus 2 into 5.002 minus 1 into 0.998. All these values we have to take from the previous iteration, which is equivalent to 4. Z6 1 upon 8, 5 minus 1 into 5.002 plus 2 into 4.001, which is equivalent to 1. 7th iteration, x7 is equal to 1 upon 15, 85 minus 3 into 4 plus 2 into 1, which is equivalent to 5. Y7 1 upon 10, 51 minus 2 into 5 minus 1 into 1, which is equivalent to 4. Z7 1 upon 8, 5 minus 1 into 5 plus 2 into 4, which is equivalent to 4. As you can see, the value of x6 is equal to x7 is equal to 5. The value of y6 is equal to y7 is equal to 4. The value of z6 is equal to z7 is equal to 1. Here we are getting the constant answers. That's why we can say the value of x is equal to 5, value of y is equal to 4, and value of z is equal to 1, because we are getting the same converging answers. So this is the Jacobi iteration method. Thank you. Welcome all. Today we are going to discuss about the Gauss elimination method. Today we will see the flowchart of the Gauss elimination method. So basically, in Gauss elimination method, we have to solve the simultaneous equations. Suppose the first equation is a11x plus a12y plus a13z is equal to d1, where a11 is the position in the matrix, a12 is also the position, as well as a13 is the also position in the matrix. So the first one represent first row, second element represent the first column. So in this case, first row, second column. In this case, first row, third column. Similarly, we have second equation as a21x plus a22y plus a23z is equal to d2, where a21 is the second row, first column, a22 second row, second column, a23 second row, third column. Similarly, we have the third equation in which third row, first column, third row, second column, third row, third column. In this way, we have to solve these simultaneous equations to find the value of x, y and z. Now, if you arrange this equation in the matrix form, so the matrix form is augmented here. So in this case, we can say the a11 is the first element of the matrix, a12 second, a13 third. In this way, we have total 9 elements in the first A matrix. This is A matrix and this is D matrix. In D matrix, we have D1, D2 and D3. Now, in case of Gauss elimination, our task is the forward elimination, and to convert this matrix type into this format, where we have to convert this A matrix into upper triangular matrix form, so that the element A21, A31 and A32 will be the 0 element. Accordingly, we have to change the element from A11 to the new A11. These both elements are different. This A11, A12, A13, A22, A23 and A33 as well as D1, D2, D3 will be getting modified after the upper triangular form. From this matrix we can directly calculate the value of Z as D3 upon A33. From the respective value of Z we can solve this equation to calculate the value of Y. Once we get the value of Y and Z, we can calculate the value of X. In this way we can do the backward substitution in this case. So the flowchart starts with start, then we define the A matrix and D matrix which I have shown previously. After that we find the value of n by using the function length d. Length of d means in our case our length of d is the 3 number of elements in the D matrix. Then we use the connector A. In connector A, now we convert the matrix into the upper triangular form. For that purpose, the I stands for the row operations and K stands for the column transition. We have to do the changes in the rows including the elements in the column. So that's why two loops are executing here. So the F is multiplication factor by which we can convert the A21 element to the 0. For the upper triangular matrix form we require these formulas. So for the first case let us take example. For the first case I is equal to 1 and K is equal to 2 because K is starting from I plus 1. So that's why K is starting from 2 to n. So the value of I is 1, value of K is 2. Now put the respective value here. We will get the multiplication factor. Multiplication factor we will get as A21 upon A11. Similarly, to get the A21 element as a 0, we have to do this calculation. A21 is equal to A21 minus F which I have calculated previously into A11. So in this way we can get the first A21 as a 0 by using this multiplication factor. Similar operations are performed in the D matrix also. If you execute this loop continuously, then we will get the upper triangular form. In next case, for I is equal to 2 and for K is equal to 3, we will get the changes in the third row. From the third row changes we can convert A31 and A32 elements as a 0. So in this way we will get the upper triangular matrix. Now connector B to the connector B. Here we define the solution as a zeros of n, 1. Here we have 3 solutions x, y, z. So in this case we will consider solution as x1, x2 and x3. So as it is the column matrix, so that's why here 3 elements having 1 column. So for backward substitution we use this formula. For I is equal to, in our case n is equal to 3. So for I is equal to 3 we have to do backward substitution. Hence we will get first x3 value here, then x2 value and afterwards x1 value. So for first case x3 is equal to d3 because I is 3. So that's why d3 minus a3 s2n into x 3 plus 1 s2n upon a33. So in this case we will get the augmented matrix. So that's why the formula is d3 minus a of 3 4 s2n into x 4 s2n. So this is the I plus 1, that is the last element of the D matrix. So afterwards we will get the value of x3, then x2 and then x1. Once we get the all values of x1, x2 and x3, we will print that answers in the form of x, and afterwards we stop the program. So this is the Gauss elimination method. Thank you.